This is Henning Mersch from Backup Automation about the Brownfield integration for OPC UA. I'm part of the product management team for TwinCat, so the software department of Backup Automation. And of course, we have a lot of machines in the field, and customers quite often ask us about OPC UA and ask us about how to deal with the fact that we have a lot of a large installation base. So let's have a look at to this topic. Typical automation environment. We have machines which are existing. These are existing machines for maybe a century or so, or even 2 or 3 centuries. So they might not even have a plug for a network cable. But you would like to do some retrofitting of this machine because you would like to improve the overall behavior of the machine without throwing it actually away and buying a new one. You would like to have these components updated without having to buy everything new. So these automation components like the controller, the actual PLC, and the IO components are usually located within a cabinet. This cabinet then is equipped to the machine, but quite sometimes the I/O system is also located directly on the components, on the engines, on the components of the machine. So we have a local but distributed system here, which needs to be retrofitted. The challenge here is how to equip such a machine, a productive machine with OPC UA technology for gathering data, for controlling the machine, and maybe the planning of the production phase. Mostly used word here is putting an edge device in front of the machine. That means either into the cabinet or connected to something else. And this edge device could be defined as a, well, let's say gateway. A gateway approach is something like collecting the network infrastructure, putting all the traffic through a gateway, and then connecting to these PLCs in the machine from outside. An edge now is putting a bit more into this device. It's not only following the traffic through the device, it's also the edge which is processing actually something. So we could put something like a UA server or a software component on this edge device and then actually use that to transform the data, not only to forward then. So this could, of course, be, from the installation point of view, very different. So we could have a virtual machine on this edge device or directly on this IPC or some virtualization technology in the back end. There are different possibilities, but from the architecture point of view, we always have one edge device for a machine. This one edge device is then capable of communicating to the machine on the one hand, so on the lower hand. There are quite sometimes different vendors, either the vendors of the controllers itself, of the PLC itself, providing some retrofit scenario, or there are other companies jumping in, providing such converter components. These converters then on the edge device are communicating to the PLC in some vendor-specific protocols in this first scenario here. So we have vendor-specific protocols, and this edge device is converting then to OPC UA for being accessed from above. We see that we have that here as a converter marked, and this is then accessed through the OPC UA client from the MES system or from the cloud system to the machine. We see in the later scenario that we'll have other possibilities here. But for the first, let's stick to that. So this is a retrofit for having a communication which is capable of security and also of companion specifications. Because if we are looking at the capabilities here, there are of course converters existing which are able to load a node set, so a companion specification syntax file, let's say, which is describing the machine in a uniform and interoperable way. Still, we are talking to the lower end with a vendor-specific format. So, for example, for backoff, this is the ADS communication channel, which has nothing to do with OPC UA, but the edge device is capable of providing the UA server interface to the upper front, and maybe even within a node set support. So, for example, to comply with the VDMA different companion specifications they are currently developing or have developed actually. Again, the OPC UA server is then able to connect to this server, and then it doesn't even see the difference between an old-fashioned machine which is retrofitted, a modern machine which is also compliant to this node set file, or another vendor's machine which is also retrofitted. All these are then in a uniform way accessible via the OPC UA server if it's compliant to the node set. Another story here is, which is quite interesting, especially for smaller companies or non-vendor companies, let's say. Quite a lot of these machines are actually already using OPC Classic or OPC DA. So they are providing OPC DA server capabilities. Maybe they are using them today already. And in a retrofit scenario, you then can put more or less any edge device in front. This doesn't have to comply or speak the vendor-specific format down below. It is able to acquire the data via the OPC DA Classic interface from the different controllers of the machine and providing it again as an OPC UA server for the client, which is running from the MES system. So if you are talking about machines from 96 on and maybe a bit later, then quite often such an interface is available already. Still, in the vendor-specific case, but also in the OPC Classic ways, we are talking about retrofitting. That means with a focus on more or less not changing the software of the PLCs itself, because this is quite often not possible, or at least it's very cost intensive if we would like to retrofit in terms of reprogram a machine. So we try to circumvent that. Another benefit from this edge device approach together with OPC UA is the server aggregation capabilities. So we are not only having one controller below. In all the slides, we already have seen that 3 controllers are mentioned on the lower level. So 3 PLCs in these terms are controlling this machine. We also have the capability to aggregate the servers into one edge device. That, in contrast to the discovery principle, discovery is just providing us a list of entry points to the different servers. Still, you need to connect as a client. You would need to connect to all the different servers. An aggregation of the servers means that we are aggregating the data into the edge device, and they are provided within one OPC UA server as one entry point for the applications from outside. To the lower level, in this example, we are talking OPC UA client, and there are quite some companies providing such aggregating capabilities for underlying OPC UA servers. The benefit is here, of course, if we have a firewall in between, then we only need to deal with one port and one connection. So the application here, the OPC UA client, only needs to connect to the edge device via one TCP connection for the whole machine which is running below. The application doesn't really recognize that actually there are a couple of PLCs below. From the UA point of view, it's one unique server which is available with all the data of the machine. This single entry point also reduces the certificate management complexity, because if we have the secured connections to to all the PLCs in the machine, then we have the issue that the application at the top needs to deal with all the different setups of the different controllers. If we have one aggregating server in between, then we only need to trust this one certificate. This one certificate then is accepted by the client, and the complete machine could be controlled via this one connection. As a last point, not actually the last point, but of course, if we are talking about the cloud connectivity, then we don't need to stick to this client server capability. We also could make use of the OPC UA MQTT, MQP mapping capabilities for the protocol, or for OPC UA PubSub, whatever is easier to set up in the situation of this existing plant, right? It's more the classical approach to have something like a SCADA or MES system as a OPC UA client connecting to the different machines. If we're talking about cloud, then we normally use mappings like MQTT mappings or OPC UA PubSub to actually provide the data to the cloud system. As an example, how such an aggregation functionality could be set up, I've a small screenshot here of one of these tools from TwinCAT, is it in this case, where you see in a graphical way you could actually set up such an aggregation component, providing on the one hand the data from the PLCs, providing configuring on the other hand the, in this case, AWS IoT system where the data is pushed. And actually, we have set up a demo for that, which I would like to describe you in the next slides. So we have done a demo where different vendors are all providing the data with the OPC UA, and this needs to be aggregated or should be aggregated into the Microsoft Cloud. So let's have a look how this looks. So we have, or we would like to have, a dashboard at the end where data from all the different controllers which are working together. So something like an overall dashboard of the complete machine. There's a Delta robot in the terms of the backoff component, which is actually providing the data. But because we are talking currently about a brownfield scenario, this machine is only providing the data in the vendor-specific format. So we are not very happy in terms of OPC UA, right? What we have done then is that we have put such an edge device in front of this machine, using the OPC UA server as a component on the edge device, talking vendor specific to the lower side, and providing OPC UA companion specification compliant information model via the VDMA robotics companion specification, and then installing a Microsoft OPC publisher on the same device. And this software locally collects all the information from the OPC UA server provided in the VDMA robotics format, and publishes this data to the cloud system via OPC UA JSON encoding. This OPC publisher component here could now be installed on all the different vendors' edge devices you see in the lower right corner. And as long as there is an OPC UA server which is providing all the data, the local data in the VDMA robotics companion specification format, it could directly be taken without reconfiguration. The OPC publisher will be in the position to collect the data, convert it. It doesn't take care of which component is below, right? It just knows the OPC UA server, take the VDMA robotics information, push it via OPC UA JSON encoding to the cloud system, and the cloud system is in the position to interpret all this data and visualize it in a way that the overall machine or the overall demo is completed. So this shows how all these components, this aggregation function on the edge service, converting the protocols and the companion bit equations, all this is fitting perfectly together for providing a retrofit scenario, a brownfield scenario, even for older machines. You have plenty of possibilities there. But one other scenario we have, I would like to talk about in the end. Quite sometimes you don't want to touch the overall machine itself. You just want to do something maybe like condition monitoring. You would like to determine when an engine needs to have maintenance or something like that. So quite sometimes the machine itself might have an edge device, might have OPC UA, but in this scenario, we have attached new I/O, so new mostly sensors, but maybe also actuators, which are connected to the machine physically. So they are measuring the vibrations or something like that, the temperatures in places where the temperature wasn't measured before. And then you are able to either from this I/O from this component, you're either able to connect that to the edge device and putting the aggregator server on that, aggregation server on that, or you directly connect it to some upper bound systems, right? So this is the I/O coupler integration capability. So directly putting I/O devices to a small device, which is actually doing no control execution. So there's no execution of a PLC program on it. It just provides the data which is collected from the reality, let's say, and provide that via OPC UA to the upper world, either through the edge device or through itself or directly connection. That's from my side. I thank you for your attention about the brownfield scenario and have a lot of fun with the next talks here in the OPC day. Thanks and bye-bye.